Hello, everyone. Welcome to the 2024 DiLCo Lecture Series on Digital Language and Communication. I'm Heike Zinsmeister from the University of Hamburg. DiLCo is a 3-year scientific network on digital language variation in context. It was initiated in 2021. It is coordinated at the University of Hamburg by my colleague Yannis Androtsopoulos and myself, and includes scholars from universities in the US, UK, Luxembourg, the Netherlands, and Denmark. DiLCo is generously supported by the University of Hamburg within the Universities of Excellence scheme, funded by the German federal government and federal states. The DiLCo network aims to stimulate scientific exchange between various approaches to digital language and communication research within linguistics, and to bridge gaps between interactional and computational research methods. To this purpose, we organize online and on-site activities such as conference panels, methods workshops, and this lecture series. Our lectures showcase cutting-edge international research by senior and younger scholars who draw on key concepts in social cultural linguistics to shed light on language use in digital communication. These lectures are recorded, and we record today. We also record today and made available in an open access repository currently located at the Hamburg University's video portal Lecture2Go. It's accessible through the DiLCo website. Each lecture is about 40 to 45 minutes, followed by discussion. Feel free to post your questions and comments into the chat during the lecture. Our speaker today, Nguyen, is a member of the DiLCo network, like all speakers in this last round of the lectures. Dong is assistant professor in computer science at Utrecht University and heads the Utrecht Natural Language Processing and Society Lab. Dong did her BA in computer science at University of Twente in the Netherlands, and holds a master's degree from the Language Technologies Institute at Carnegie Mellon University in Pittsburgh. She obtained her PhD, again, at the University of Twente in the Netherlands. During her studies, she completed internships with major language technology companies like Facebook, Microsoft Research, Google. Since 2019, she's assistant professor at Utrecht University, where she received the Non-Early Career Award, which is of the Dutch Science Academy. She works in natural language processing and is well known for her work in computational text analysis for social science research questions, with a particular focus on social media data. I think you could say that her survey paper on computational social linguistics published together with colleagues in 2016 defined the kind of emerging research area of computational social linguistics as a new subdiscipline, which tries to model and analyze language variation and change using computational approaches. Dong did also major contributions in natural language processing for computational social science. And another area which she works on is explainable NLP, which has recently become even more important due to the emergence of these large language models and generative AI. She has published numerous papers at major conferences and in journals, and was invited as keynote speaker and also invited to serve as area chair in all the main computational linguistics conferences. Thank you for being with us today, Dong, and the floor is yours.
Thanks, Heike, for this very extensive introduction. It's really nice to be able to present today. So I'm going to talk about social perceptions of language variation, looking both at human data and data collected using large language models. Quite some part of what I'm presenting today is still work in progress, so I'm very interested in also discussing with you, and if you have any feedback or ideas, I would be very open to hear them. So let me just start with a broader outlook, right? So I work in the field of natural language processing, so the automatic processing and analysis of natural language. And of course, natural language, there are many languages in the world, Dutch, English, but also minority languages and so on. But if we look at the field of NLP, well, it primarily focuses on English, right? If you look at the studies that are performed, the tools that are available, it's improving nowadays, but still the focus is very much on English. And actually, if we look at this even more critically, you would say NLP focuses primarily on, let's say, standard English. And so there are quite a lot of studies that show that these NLP tools, when they're applied on other language varieties, the performance often drops. And so language variation in natural language processing is often seen as noise. There are tasks like text normalization, where the goal is to transform, let's say, non-standard language or non-standard text to a standardized form. And also when researchers are creating data sets, they use heuristics to improve the quality of the data. And often this involves also downgrading or sometimes even filtering out non-standard language. However, my perspective is quite different. I'm very much interested and think that language variation should be taken into account when building NLP models, especially because these models nowadays are really need to understand and engage with language users in real-world context. And so my overall research goal is to really think about how can we model and integrate language variation into these NLP models. And one of the questions that we then have is, well, what kind of language variation patterns or information are NLP models already picking up? And there are some studies, including some work that I did, that shows that there's some evidence that these models already pick up on quite interesting patterns related to variation. So to illustrate this, I'll give an example with word embeddings or word web stations. I think many of you know what these are, but because it's a mixed audience, I'll just illustrate it to be sure. So these are key components in modern NLP models. And so the idea is that words or other text units are represented as vectors, basically list of numbers. All right, so on this slide, you see two three-dimensional vectors, A and B. And these vectors can also be seen as points in a high-dimensional space. So in this case, in a three-dimensional space, let's say. In natural language processing, when we're representing words as vectors, or sometimes even whole documents as vectors, the number of dimensions is higher. So like 50 to, let's say, 1024. And the key idea is that words that are similar to each other, that they are closer to each other in this vector space. And here's an example of how such a vector might look like. And these vectors are automatically learned from data. And the main idea is that they're learned by looking at the context in which words occur. Right? So suppose here we have three different snippets of text where a word is masked. And if you just read these snippets, then I think you probably have a pretty good intuition of which words is missing there. Right? So characteristic features of, well, good vegetables for, and so on. So actually the word that's missing here is rabbit. It's just to illustrate that by looking at the context of words, we can get a pretty good sense of basically the meaning of the words. And this also means that these models that are trained, they're often trained on these tasks where they need to predict a missing word. And the idea is that to be able to do this task, they learn information or knowledge about language, but also knowledge about, let's say, the world, right? Knowing like this is the capital of this country. And even they pick up on language patterns that are related to, let's say, social factors. And so one study that I did a few years ago with Jack Grieve was asking, well, what do word web stations encode about variation? And we trained different word web stations on social media data. So here's an example based on Reddit data. And so we train a model on Reddit data, and then for each word, we get a word representation. And then we can map them onto our 2D plane. All right, so here we're showing you different forms of the word nothing. And this is using the SkipCam algorithm. And just by looking at where the words are positioned, I think you can probably see that there seems to be some structure in it. Right? And the interesting thing is that this particular algorithm doesn't look at the spelling of the words at all, just at the context in which these words occur. And then we see that lengthened forms are clustered together. We see a cluster with the standard spelling, but also forms that are more likely or seem to be misspellings. And we see these clusters that reflect dialectal pronunciation, including G-dropping and other forms. And I would say this is not surprising because these different spelling variants are not just used randomly, right? They occur in specific context, and we also see that these models pick these up. So today I want to talk a bit about large language models. And large language models are really based on the same idea. They're trained on huge amounts of data, much more data than the previous model that I showed. And there are also, like, web data makes an important part of the training data of these large language models. And so it's very likely that they will also pick up on different patterns related to variation in language. And the basic task is very similar to what we've seen already, word prediction. So the questions that I want to talk about today are, well, which social attributes do large language models associated with language variation? And how does this compare to humans? And the reason to do this is that I think it's very interesting to think about how can large language models potentially be used to, let's say, support social linguistic research in the future, right? So if these large language models can pick up on interesting patterns related to variation, could they maybe be used as a way to measure or discover social meanings of linguistic variance? Not as a way to replace human participants, but more as a way to kind of complement other data collection or experimentation methods. Secondly, large language models are increasingly used in society. And so it's also important to uncover associations that large language models have with different ways of writing, right? Because if they're used in downstream applications like hiring or quality judgments, we need to know what kind of, let's say, biases these models contain. And so there's this recent study from this year by Valentin Hoffman and others who look at this particular case in looking at African American English, and they also show that these models have negative associations or evaluations with text within African American English. And so today I'm going to focus specifically on spelling variation on social media. So on social media, we see a lot of different ways that people spell words. As an example, someone can ask, how are you doing? Or how are you doing where the final G is dropped? Or spelling it in the third form that I'm showing you there. And just like variation in spoken language is used for social meaning making, spelling variation used online can also be socially meaningful, right? And I would say that spelling variation tends to be underexplored in social linguistics compared to some other types of variation. But there are already a few studies that have looked at spelling variation and social meanings. So unconventional spellings tend to be evaluated as being less educated, less formal or more relaxed. They're also seen as being more friendly or more original, and unconventional spellings tend to be associated also with younger writers and female writers, so also associations related to actually the author of the text. But many of these studies are either qualitative or they focus on really specific phenomena. So actually for our study, we had to also collect our own data. So that's what I'm going to talk about now. So how we collected human ratings. And then after this part, I will talk about how we collected basically ratings from large language models in a similar way and how that compares. So when we collected data from humans, basically the question is, well, what social attributes are associated with spelling variation? And so we presented different forms of tweets to human participants and asked them about the associations. And so this builds on the speaker evaluation paradigm in social linguistics. So this is joint work with Laura Seal, but then adapted to the written setting. And we looked at 7 different types of spelling variation. So G-dropping, where the final G is dropped, lengthening, actually 2 different cases, one where variation, where it reflects variation in pronunciation, and also one where there's not a clear spoken counterpart. Vowel omission, so for example, I call you after this weekend, and then weekend where the vowels are omitted. Number substitution, swapping letters, so just swapping letters in a word like certainly, and keyboard substitution, where one character is replaced by a character that's nearby on the keyboard. And these tweets were coming from a large Twitter corpus that we had, but then we also manually edited these tweets to make them a bit shorter and remove some signals that were very much pointing towards, let's say, the identity of a person. So we really wanted to make them more, let's say, more neutral, to have people focus on the spelling variation. Out of these categories, the last 2 are more likely to be unintentional, right? So letter swapping and keyboard substitution are more likely to be unintentional, while some of the other cases maybe are more likely to be intentional in many cases. But of course, we need to be careful with this distinction because we can never know for sure. But this is something that we would expect would also play a role in evaluations of people. So this is how the data collection looked like. We presented the human participants with pairs of tweets, one with the conventional spelling, one where one of the words was replaced with an unconventional spelling. And we also underlined the specific word that we wanted the participants to focus on. And then they could slide to indicate the informality of the according to informality, carefulness, as well as we asked them to guess the age. And every participant saw 21 tweet pairs, so 7 for the informality rating, 7 for carefulness, and 7 for age. And these tweets were randomly selected, and also the ordering between the conventional and unconventional form was also randomized to control for order effects. So the data collection was through Prolific. We had a few criteria, like the participants needed to come from the UK. So Prolific is a crowdsourcing platform. First language should be English, no language disorders. And we collected the data in September 2023. In total, we collected data from 230 participants. Looking at the final data, we had to exclude a few participants because we also asked them for their location, for example. And if their location was not clearly in the UK, then we removed these participants just to be sure. In the end, the final data set contains data from 217 participants, which in total is 9,114 ratings. And so on average, we have almost 22 ratings per item. So an item is a specific tweet variant and a social attribute like formality or carefulness or age. And this is much higher than what we typically would do in natural language processing, where for one particular text, we sometimes get 1 or maybe 3 or 5 different ratings or annotations. This is much higher also because it's a very subjective task. We also asked participants for some open questions to get a sense of why they gave certain ratings. So we asked them, for example, do you have an idea about how people use language on Twitter and so on? And what we saw was that participants, or at least some participants, had very strong attitudes, especially also negative attitudes towards bad spelling. And some participants also made this distinction between, let's say, deliberate and accidental variation, right? So saying relating to like identity work, or it's used by young people, it makes people look trendy and so on, or things like this is lazy or incompetent. But generally, I would say that looking at the open questions, there was quite some considerable language awareness about identity work with language. So here are just two examples of answers that people gave at the end of the survey, right? So if we look at the left, typos imply a lack of care and attention, but deliberate misspellings make me think people are young, right? So this person makes this distinction between, let's say, deliberate and accidental variation. On the right, we see something like very formal writing, if not used by someone tweeting for work purposes, can give the impression that the writer is out of touch. So here we see that it also depends on the type of account, right? Is it like a professional account or not, and so on. So these were the demographics of the participants. So about 59% were female, 40% male, 1% identified as other, and 67 of the participants had a Twitter account. And the age, most people were between, let's say, 30 and 50 years old. So here are a couple of example tweets, just a sample of the tweets and their average formality ratings, just to give you a bit of an impression of how the data looks like. Right, so if we look at the bottom 4 rows, we see that the formality ratings, they drop quite substantially if you compare the conventional and the unconventional form, right? So see you tomorrow, tomorrow where the 2 is used, has a really low formality score compared to 1 where tomorrow is written in a standard spelling. What we also see is that just let's say the content of the tweets also has an effect on formality, right? So here, these are tweets that just have the conventional spelling, and we do see formality differences in the formality ratings. So here are the results or the scores for carefulness and age. And we see something similar as well. So we see big differences between the unconventional and the conventional form, being rated as being less careful, and also coming from younger users. And we see again different scores just depending on the content of the tweets. If you then look at the specific types of spelling variation that we looked at, what we then did was comparing the drop in weighting, let's say, by going from the conventional to the unconventional form. So, for example, if we look at this particular value, this means that when a tweet contains number substitution, the formality rating on average drops by 55.64. What I think is interesting is that for keyboard substitution and letter swapping, which we expect to be more often, let's say, unintentional, here we see a smaller drop in formality compared to the other types of spelling variation, but actually a larger drop in terms of carefulness compared to the other types of spelling variation. We also see very few differences looking at the 2 different types of lengthening, like pronunciation and spelling. All right, so we collected a bunch of human data, and now I'll talk about some first results with large language models. And today I'm presenting results with 2 different models. We also explored a few others, and actually by now new models have come up, so I hope to run basically these experiments on the new models soon. But we looked at GPT 3.5 by OpenAI. So this is basically a closed model that you need to query using an API. And we looked at Llama 2 jet version. So this is developed by Meta, which is open, so you can actually just download the model to your computer or your server. And that model is available in different sizes. And so the experiments that I'm presenting here is based on the 13 billion parameter model, which is, I have to say, not the largest. So there's also a 70 billion version. And so that's also possible, but just takes much longer to query. Also in both cases, or with most models, they're trained on a lot of web data, but we actually know very little about the specifics. But it is very likely that they will have seen quite some spelling variation in the training data as well. So then we explored different ways of prompting these models. So basically different ways of presenting the task to these models. So in the first setup, the tweets are presented independently of each other. So each time the model just sees one tweet, like I should hope so, and then either the conventional spelling or the unconventional spelling, and then it's asked to rate, let's say, formality, carefulness, or given age estimates. In the second setup, we actually show the pairs of tweets. So both versions, the conventional and the unconventional version, they are presented in the same prompt, right? And so this is what I call the paired version. And this one also resembles more closely the human experiment, because when we were collecting data from humans while using Prolific, on each page they also saw both versions. And like with Prolific, we randomized the orders just to control for audio effects. The third setting that we tried was actually simulating the order of the tweets that were shown to each participant, because for each participant saw a random selection of tweets, and then the order was also random. So basically in the third setting, we just simulate each participant by showing the tweet pairs in the exact same order. For the other two settings, we also collect multiple ratings for each tweet or tweet pair to match the number of ratings that we have with the human data. In terms of the prompt formats, so the text that we send to the models, we have a system prompt. So the system prompt contains the basic instructions or description of the setting. And we tried to mimic the instructions that were provided to the human participants in Prolific as much as possible. But we also made some few changes. For example, in pilot experiments, we noticed that these large language models would frequently say, I can't give a response, or I can't say anything about formality or the age of the person based on just the text. And so that's why we added the sentence, you must always respond with your best guess, even if you are unsure. Then there's a user prompt. So this contains the specific tweet or tweet pair that we want large language models to rate. The humans participants, they saw a slider. In this case, we just asked the models to return a number from 0 to 100, matching the scale that the participants also saw. And the way that the tweet is presented, we can't underline something like the participants saw, but we put tags to indicate the words that the model should focus on. In the paired setting, it's very similar to the previous setting, but then we changed the instructions slightly to indicate that each message will be displayed in two different versions. And then we show basically the two tweets below each other. So here are the results for Llama 2 and GPT 3.5. By correlating the ratings between the human ratings in Prolific and the ratings provided by the large language models. So what I think is a substantial difference looking at these tables is that the paired setup, so the setup where large language models are seeing both versions of the tweets, they lead to much higher correlations than the setting where these models are seeing each tweet independently of each other, right? So for example, with GPT 3.5, looking at carefulness, it goes from let's say 0.70 to 0.93. So that's a big jump. And the same holds for Llama 2. In these results, GPT 3.5 achieves higher correlations with human ratings than Llama 2. But I have to say that Llama 2 is the version that we used was only the 13 billion, There's also a 70 billion, which is larger and expected to perform better. And nowadays there's also Llama 3, right? So we have to be a bit careful in terms of really comparing, let's say, different models, but at least in our results and the specific versions that we used, GPT 3.5 had much higher correlations than Llama 2. If we then look at the sequential setup, right, where we basically simulated each participant and showed the tweet pairs in the exact same order, then we do see consistent but small improvements for GPT 3.5. But for Llama 2, actually, the performance drops quite substantially. This surprised me, and we probably need to do more experiments to figure out what's happening, or perhaps change the instructions or the settings slightly. But what I've seen so far is that when we present the whole sequence actually to Llama 2, then the previous tweets and the ratings that the model provided to these tweets is influencing the current rating too much. So suppose that the previous tweet pair that was presented to the model, in that tweet pair, the unconventional form was presented first and then the conventional form, and the models asked to rate, let's say, formality. So then the first tweet received a lower rating. And then suppose that in the current tweet the order is changed, Llama 2 would be too much influenced by the ratings that it provided for the previous tweets. That's at least based on what we've seen so far, but we need to also do more experiments to figure out what is happening there exactly. One thing that we did notice was that we also looked at the correlations by looking at the weighting differences. So what I showed you before in this table, we just correlated the raw weightings for each item. And here, for each tweet pair, we look at the difference in terms of the ratings. So the difference between the conventional and non-conventional spellings. And then we calculate the correlations, and then the correlations really drop substantially, and in some cases also becomes non-significant. So this suggests that a lot of a big part of the high correlations that we saw earlier can be explained by basically the difference between unconventional and conventional forms. But if we zoom in on the more nuanced patterns related to, let's say, the different types of spelling variations, then correlations become much lower. Here are a couple of examples. So this is the same set of tweets that I showed you earlier with the average human ratings for formality. So 0 is very informal, 100 is very formal, and the average rating provided by GPT 3.5. And it doesn't look bad, right? So if you look at the last 4 rows, then we also see that with GPT 3.5, going from the conventional to the unconventional spelling, there's a big drop in formality. And also, if you just look at the first 4 rows, then I would say the ratings by GPT 3.5 actually don't look bad in terms of formality. However, if we then look at these different categories of spelling variation that I described before, and we look at the average drop in ratings, so with number substitution, on average, the formality ratings drops by 55.64. So this is what I presented you earlier. So now I'm also showing you the average results based on GPT 3.5 in sequential setting. And here I think we can see that this seems to align less with humans than we might have expected, right? So for example, keyboard substitution and letter swapping. With humans, we saw that in terms of formality ratings, the drop is relatively small compared to some of the other spelling variants. But with GPT 3.5, we don't see that, right? And also, if you look at lengthening, for example, with GPT 3.5, there seems to be some difference between the 2 different categories of lengthening that we didn't see with the human data. So zooming in on the specific types of spelling variation, I would say the results between GPT 3.5 and humans is less comparable. With the human data, we had almost 22 ratings for each item, and also with the large language models, we prompted them multiple times, so basically to match the number of human data, of human judgments as well. And we did this by setting the temperature. So this is a parameter that we can set to 1. This is a value that's often used. It's kind of a default setting. And that also means that it's not deterministic. So when you ask a query model multiple times, you get different answers. And the temperature is influencing, let's say, the diversity of the output. So it's also going to have an effect on the standard deviations. So it can be that the results would change if we would use a different temperature setting, right? But for this particular setting, we see that the standard deviations are lowest for age, for both humans and the large language models, which makes sense because most of the age, let's say, guesses or estimates are around, let's say, maybe age 20 to 40 or something. At least it's very unlikely that a Twitter user is, let's say, is 90. And the GPT 3.5 ratings, they tend to vary less than those by Llama 2. As a next step, it could be interesting to try to get a better sense of why these large language models provide certain ratings, right? So we can also ask these models, right, can you explain your ratings or your reasoning? So here are just a few examples with ChatGPT, where the model says, well, the suggested writer is likely trying to maintain a proper and more conventional tone, or the suggested writer is using a more relaxed and less formal tone. So this is the case of G-dropping. Or here, this is an example with number substitution and asking about carefulness. And then we also see things like lack of concern for proper spelling, formality, and so on. I haven't analyzed this systematically. My sense is that the things that are mentioned are relatively high level. And there's a caveat that there's actually no theoretical guarantee that the explanations that these models are giving is actually the reason why they provided the ratings, because in the end it's just like generating text. So we have to be very careful with interpreting this as a real explanation. But still, these descriptions can be an interesting source to also better understand what kind of associations these models have with different ways of writing. So taking a step back, I think there are some very interesting open questions that are now emerging related to large language models and language variation. So we know that humans, but also large language models, they can have they can evaluate language variance in a negative way in certain contexts, right? So certain types of certain ways of writing can be associated with, let's say, being sloppy, being not intelligent, and so on. And these associations have been seen by people, but also it's very likely that large language models also have such associations. So then the question is, should we intervene, and how and when, right? So if these large language models are just used as a way to, let's say, analyze language, to learn more about language and the different, let's say, associations that are encoded in these models, then these negative evaluations are something interesting that we want to, let's say, measure, right? But if these large language models are used in downstream applications, for example, for hiring or recommendations, then of course they could have a harmful impact. So these are interesting questions that I hope the field, natural language processing, but also social linguistics will start thinking about, right? Like, how should we handle language variation, and should we intervene in the case of negative evaluations? Secondly, there's this broader question about invariance versus adaptation. So there's quite an interesting paper coming out this year by Lee, Lucy, and others, where they talk about this question. So if we look at AI and fairness, there's a lot of discussion about what it means for a system to be fair. And so when we're talking about LLMs, and in particular the outputs, then there are basically two different options. So one is invariance. So this is saying we want to have identical behavior across different social groups. So a lot of the fairness work in AI focuses or takes that perspective. But another perspective could be we actually want these systems to adapt to, let's say, the different social groups that they are interacting with. This could perhaps facilitate the communication, but also carries risks like stereotyping and so on. Right, so which of these is more desirable is an open question. The study that's coming out this year, there they do a user study basically showing that people have a lot of different opinions about this. But I think this is a very interesting question also to think about moving forward, and something that also I believe social linguists might have interesting insights for. So to conclude, in our current experiments, on the one hand, the LLM ratings, they correlate quite well with human ratings, but it seems to be that this is mostly caused by differences between ratings of like unconventional versus conventional variants. And if we zoom in on the specific types of spelling variation, then the correlations become much lower. But more broadly, I think we live in quite interesting and exciting times related to large language models, and also an opportunity for social linguists to either use these large language models or think about how to improve these large language models. There are many opportunities that are emerging, but also many important open questions that I hope people are going to start thinking about. So that's it. Thank you for the attention. I'm looking forward to discussions or any questions.
Thank you very much. So we take questions both in the chat, and also you can raise your hand, such as Olga just did. So Olga, your question.
Okay, thanks a lot, Dong. Very interesting talk. I guess I'm interested in the explanation of the correlations in the large language models. So if you say, for instance, your observation is that age correlated the most, right, with some like informality, I think it was, or something. Right. So my question is, do you have a guess why? So is it that, I mean, especially for ChatGPT, is it that, do you guess, I guess why, in the sense of, does it really look at the context and derives from the context some features, let's say topics, for instance, right? Younger people might talk about other things, right? Or is it that it might have some source, let's say someone who is very important. I mean, I don't want to say that somehow importance is encoded in these large language models, but it could be, let's say, a president, yeah? The president says, younger population use more typos or whatever, you know, then it takes this as a source for, as we humans also do, right? I mean, the fact that you observed some correlations in asking people doesn't necessarily mean that younger people do more often. If you would really do a corpus analysis, so you would need to do a corpus analysis to discover that indeed there's more informality, whatever, correlation between age and informality, right? It could be just that people think because someone said so, right? It's I don't know, whatever, it's common sense, right? So I wonder whether that could be also the case for large language models. So my question is, I guess, is are large language models different in this sense? So do they derive the information from really a distribution of words, right? Then we would have a different, that would be actually then interesting, for me at least. to see that there are actually commonalities between humans and large language models with respect to judgment of variation. Yeah, sorry for this long.
I think it's a very interesting question. So I think it's very good points that you point out that also when we ask humans or the prolific participants about their associations, or when we ask them to provide ratings, right? That's just what these participants believe, right? Or what they associate. It doesn't necessarily correspond with, let's say, real-world data, like corpus data. So I guess I want to say two things. So in a previous study with Jack Reeve a few years ago, we did also look at corpus statistics to basically see how these different variants were distributed in like Reddit and Twitter, and then also looking at word embeddings. In this case, it's very difficult because we just, for both of these models, actually, we don't know what model what data they're trained on. So we have no idea. Maybe we could train like smaller models with similar architectures from scratch on very small data sets, and then try to track how these associations emerge as these models are training. That could be very interesting, but as academics, we would only be able to do that on a smaller scale. But that could be actually super interesting, I think. My guess is that these models pick up on basically statistics in the corpus data that they are seeing, but also they might have, and again, I don't know actually, right, but they might have some like blogs or websites in that data that talk about different ways of writing with negative or positive evaluations. And things like formality and age in particular could also be partially, basically derived by like corpus data, right? So for example, the training data might also contain cues about the specific setting, or it might contain some cues about the person who wrote the text. And so in that sense, these models might also pick up on some of these associations. But it's a very interesting question, and something, of course, that I would love to research. So this is really just, I would say, first study. But the difficulty is, at least with these very large models, that we just don't know what data they were actually trained on. Does that answer your question? I'm happy to.
Yeah, thank you. I would definitely exciting to see your progress.
Okay.
Yeah.
So Alexander, you are first.
Yeah,
I can ask my question later.
Hello, it's been a while. Good to see you.
Nice, good to see you.
Interesting, great work. And also great to see, like, I use Prolific all the time, so it's like always getting used, like, because I always get great data from there. I guess just a comment on like the training data. So so I haven't worked on these models, but the models that I'm familiar with and how they're trained is that there's a lot of filtering goes on, and so it's this this drive for like high quality data, which is this same thing in my work. A lot of models that are trained on data that have emoji stripped out, because, as you said, these things are just seen as noise rather than actual useful aspects of language, or real aspects of language. So I guess maybe my question is, or more of a comment, I guess, is have you looked at, because often with these models you can fine-tune them, or even without fine-tuning them you can like really prompt them. Have you looked at whether these biases in models can be overcome with fine-tuning, or with extreme like prompt engineering or anything like that?
Not yet in this specific context. So we have a paper at FACT this year, which is slightly different, where we look at basically, well, I'm not sure if you can call it large, but let's say language models and co-reference resolution, right? So looking at like pronouns in a particular let's say non-binary or gender-neutral pronouns. And there we see that with artificially changing some data, like augmenting some data in the training, just maybe a handful of data already can impact these models a lot. So that's in a slightly different setting. In this setting, we haven't done that yet, but this whole question of what's in the training data and how that's influencing the models is something that I'm super interested in at the moment. Yeah.
It seems like because you've got the data to fine tune these models here with the examples. You know, the data from these experiments, you know, probably could be used to you know, instruct LLMs to you know, and see if, you know, like how much prompting do they need, how much tuning do they need to overcome these biases, would be an interesting question, because if it's easy to do, then it's, you know, I think it'd be easier to convince people to fine tune these models after the fact, or instruct them on how to prompt them, rather than at the training step initially. You know, because that is a lot like a torturous process, which is just, and you're right, like no one really knows, like no one's looking at the data because there's so much of it. It's all very like impressionistic, overly conservative stripping out of stuff. So
yeah, absolutely. I think I mean I'm in favor of, let's say, trying to get high quality data, but this whole question of what we actually mean with high quality is intriguing, but also very difficult. And I think current heuristics can sometimes be quite problematic.
Yeah.
I have a question on the prompting and also on the human evaluators or annotators. So on the prompting, did you also use control prompts, for example, with two versions of the same formality level, just switching, for example, the pronoun she and he, and then ask, whether there's a formality difference? And this is the first question. The other is, did you also look into the human evaluators? Did you form personas or so to see whether the humans or the systems, whether their evaluation, the explanation they gave corresponds to their statements? So you said you didn't do it with the systems yet, but did you do it with the human evaluators?
So I'm not sure if I understand the second question. So what do you mean exactly with using it for the human evaluations?
So you asked the human annotators to comment on their judgments. And the question is whether, and you showed us some examples of the human comments.
Yeah.
And the question is whether you looked into whether their comments, whether you could form personas, like different groups in the set of 21 evaluations per item or evaluators, so that you could form like groups of people who judge similar but different from other personas, from other groups, which is kind of reflected in their comments they made.
I think this, apparently it's my intense question. I think this is, so we did of clustering of like the responses. We did a bit of clustering of the responses, but not exactly how you describe it. So I think that would be very interesting to really group people. So far we looked into like, can we cluster keywords or certain responses, but not really, let's say, clustering the participants or creating personas. So I think that would be super interesting. In terms of the first question, in some pilot experiments a long time ago, we did try a few of these cases where basically we presented different sentences with changes that we would expect wouldn't matter, right? But we haven't done it with the final data yet, so that would also be very interesting to see. Yeah.
Yannis?
Yes, I'll ask one. Thank you so much. And I think the discussion is very interesting as well. So one thing I noted down is do large language models have language ideologies?
Yeah.
So, I mean, answering this could pull you towards thinking about sentience, and so do you need agency and sentience in order to have language ideologies? But then again, LLMs sort of reverb or mimic or sort of simulate language ideological statements that are part of their database. And so one question is, what is actually the training data? But another question is, to what extent can we make guesses about the training data from the qualitative verbal outputs of the large language models? So on slide 61, I think, you had some examples of here. And what happens with ChatGPT is that it copies the distinction between careful speech and careless speech, for example. So you see there a binary that is used to evaluate language. And one could ask, where does this come from? And what kind of human discourse is there? We don't know if it's in the model, but we can look whether it's somewhere else in databases, in newspaper data, in, let's say, school books or whatever, in received wisdom about language and about language style, where the distinction between careful speech and careless speech that underpins the evaluation of variation comes from, okay? And one way to pursue this line of thinking would be to compare the LLM output to the human output, not just at the level of the scores, but also at the level of the verbal reasoning of the statements and the evaluations. And that would be really an interesting instantiation of this interface between more computational and more discourse analytic work, I think.
Yeah, absolutely. So we have different setups in terms of collecting data. We also have this other setup where we basically give people just the freedom to come up with keywords or something, right? And we also have these explanations. So these are all very interesting things that we would like to study further. We started with scores because that's just, let's say, more straightforward to compare. But definitely, I don't think this is the final.
Yes.
Yeah, and I think this training data question intrigues me, and it would be very interesting to perhaps also, there are some efforts of training, let's say, very small large language models on very small amounts of data. That might be a way to just see, for at least a more a data set that we would create ourselves, right? Where we know exactly there, just to see what happens and how quickly these things are picked up by the models as well.
I mean, this seems like a great, let's say, technique to create a sort of discourse analysis of metalinguistic discourse by LLMs. I mean, if you look at the second statement, the use of abbreviations like this often indicates a lack of concern for proper spelling and formality. So this is quite disparaging, actually, and generalizing as well, right? And it certainly does not reflect what happens on the ground. So if you see where this GR8 occurs in society, sometimes it occurs in very strategically styled texts, in advertising, in popular culture and things like that. So, and I think one thing that Olga said, which is absolutely true from the viewpoint of language ideologies presuppose variation on the ground. So they presuppose that certain kinds of people speak in certain ways without there always being empirical evidence for that. It's just that presupposition is built into a language ideological statement or evaluation or comparison. So that's really exciting in that respect as an entry into this interface of computational and discourse as well. Thank you.
Yeah. So I think that these are very interesting comments, right? And so LLMs in itself, they can be just a very interesting tool to learn more about language, right? Even if they can have like negative associations that we might not want if they're actually used in practice.
Yeah.
As a researcher, that they could still be very interesting research objects if they pick up on these things. Yeah.
Okay. So time is up. I would like to thank you very much, Dong, for this, as always, interesting presentation. And I like to thank also the audience for their questions and discussions. And I think, Yannis, do you want to announce the next presentation?
Yes, the next presentation, the next talk, and the one before the last will be by Alexandra Georgakopoulou on June 20. Today in 4 weeks' time, June 20 with Alexandra Georgakopoulou. Thank you.